Hello everyone. So this time we'll be talking about how we can determine our coefficient of static friction, and then talk about, well, are we going to tip? Are we going to slide? Which one's it going to be? So let's look at this. And let me get I'll keep my point up now. So first off, this is not something that's necessarily straightforward. You might think, well, if I know the weight perfectly, I get some sort of force gauge and I pull. And that can work. If you can just pull it, you can eventually figure out, okay, it seems like it's just about up there. It moved. And if you're watching really carefully, you can watch the force gauge. Especially if you've got a digital gauge, it might be very simple to do that. Okay. Now, eventually though, there's an easier way to do this, because eventually you're going to see it pop. But most people don't have access to such advanced force gauges. At least I don't. We like a fishing gauge, but that's just not enough to figure this out. So what you could do is something a bit different. What you can do is you can say, okay, I'm going to put it on an incline. I'm going to keep on increasing the angle of that incline. And eventually, it's going to begin to slide. And it's much easier to understand what the angle was when it began to slide than it is to figure out the exact force you're pulling on. Now, if you're wondering why that matters, well, if you take tan of that angle in radians, that doesn't matter, but tan of the angle, that will be equal to your static coefficient of friction. And that's just because of the ratios here, you can see right here. Or we have our force, our static force right here, which will be at the maximum at the point when it's just about to, but has not quite slid. If we do this, you can see that these two cancel. So that's what we're trying to figure out right here. We can do that just by telling the angle of the surface that we are have our block on. So here's a little diagram of that right here. You take a block, it has some sort of known weight, you put it on an inclined plane, and you keep on increasing that plane until it finally begins to slip. And then once again, we're going to say that it's in equilibrium, and this is just before it slips. So just before it slips. So our frictional force is the maximum frictional force. If we look at this, you see, okay, well, we've got force of friction that's kind of pointing up at an angle. We've got our normal force also pointing up at an angle. And we've got our weight right here. To make things simpler, it's just nice to make our y-axis along the normal force and our x-axis along the surface. And then we have the weight broken up into two components. And once again, we come to the exact same solution we saw earlier, but this one honestly just makes a little bit more sense when we come to the derivation. Because what you see here is that the weight drops out, because eventually we're going to take the ratio to figure out what the angle is. And so we have weight sine of theta over weight cosine of theta, and that will leave us, with coefficient of friction is equal to tan of theta. So this allows you to find the coefficient of friction between any two materials that can contact each other. So if fire doesn't work, we're trying to figure out gasoline and fire. Fire doesn't really have a coefficient of friction either way, hopefully. Never actually thought about that before. Well, that's not important. Let's keep on moving on. And you know what? Actually, I'm going to stop right here because I want to spend more time on tipping and sliding. I don't want to rush it. So just to summarize, we looked at the coefficient of friction and where that comes from and how we can calculate it. And the best way to do it, in my opinion, is the sliding method. So you put it on an incline, you see, okay, has it slid? Has it not slid? And when it gets to that point when it's just about to slide, like you go any farther and it slides, you realize it's in equilibrium at that point and that your frictional force is equal to the maximum frictional force. Then you can simply solve these two equations, which I have, both of these. You see, okay, I divide one by the other, I get this right here, I get a ratio. Eventually that will be tan of theta. And then since you know what the angle is, you can then determine the coefficient of static friction. This is static friction, not kinetic friction. So I hope this helps you, and I'll see all of you next time as we talk more about whether things slide or tip. Bye-bye.